Welcome to the VPT channel, where we experiment with the relationship between gas pressure, temperature, and volume.
And on the VPT channel, we have Carlton Moeller, Isha Banerjee, and Maggie Berry.
The purpose of this lab is to explore the difference between gases' volume and temperature, pressure and temperature, and volume and pressure.
For the materials, we will need one syringe, two balloons, a pressure meter, a heating plate, a bowl with cold water or ice, a drying oven, a thermometer, ruler, and string.
For this lab, wear your goggles, tie up your hair, don't wear any loose clothing, and don't touch the heating plate.
The procedure to discover the relationship between the pressure and temperature is as follows. You are going to take a syringe at a constant volume and measure the air pressure with the room temperature syringe. Then you're going to take the syringe and put it in a cold bath with ice or water, and you are going to leave it there and let it cool. And then you are going to test the air pressure of the syringe. And then lastly, you're going to take the syringe and put it on top of a hot plate, but don't actually put it on top of a hot plate. Let it warm and you'll hold it. And then after it warms up, you're going to take the air pressure of that syringe, and that way when you're done, you will be able to compare all the air pressures according to the different temperatures.
First, we are going to blow up two balloons to the same size and circumference. Second, we are going to measure the circumference. Third, we heat one balloon with a heater. Fourth, we then record observations and measure the circumference of the balloon that was in the heater. Fifth, we cool the other balloon with ice water. And sixth, we record observations and measure the circumference of the balloon that was in ice water.
In this part of the procedure, we will be exploring the relationship between volume and pressure. The independent variable in this procedure is the temperature, as it will remain the same. In order to see the relationship between volume and pressure, we are going to take a syringe filled with air and attach it to the pressure reader. Then we will slowly reduce the volume in the syringe by pressing down the pump, and we will then see how the pressure within the syringe is affected by the reduction of volume.
So we blew our balloons originally to 56 centimeters in circumference.
After 3 minutes of being on the hot plate, the balloon's circumference turned to 60 centimeters, and then shortly after, it popped.
So that means that as the temperature increased, the volume increased. Yes. After the balloon was in the freezer for 3 minutes, the circumference is 54 centimeters, which was less than the original 56, meaning that as the temperature decreased, the volume decreased.
So in this experiment, we're going to be seeing the relationships between volume and pressure. When we have the volume at 20 millimeters of this, the pressure is going to be at 82 kPa. But then, once we decrease the pressure down to 15 millimeters, see the pressure? It's increased to 108 kPa. The inverse works as well. When we decrease or increase the volume from 15 milliliters to 20 milliliters, the pressure drops.
For our third mini-lab, which will determine the relationship between pressure and temperature, we have a flask with a pressure reader that is going to be put in the ice bath for 3 minutes. Then we're going to read the pressure. Then we're going to take that flask, let it cool, and put it on the hot plate and read that pressure. As you can see, as the temperature goes down, the pressure goes down as well. Now we are going to put the flask on the hot plate, and as you can see, that as the temperature increases, the pressure increases as well.
Question 1. The relationship between pressure and volume is that when volume goes up, pressure goes down, and when volume goes down, pressure goes up. We observed this in our lab when we connected the pressure monitor to the syringe, and as we decreased the volume, the pressure went up, and the inverse was true as well.
The relationship between pressure and temperature are directly related, meaning that as the temperature goes up, the pressure goes up, and vice versa. Our design measured this relationship by keeping the volume constant and by monitoring and changing the temperature. we put the flask at a warmer temperature and we watch the pressure rise. And then we put the flask at a cooler temperature and watch the pressure in terms of kPa decrease.
So for our experiment testing the relationship between temperature and volume, we used 2 balloons of the same circumference to test the circumference in heat and cold, as well as the baseline room temperature test. So we noticed that the balloons we heated increased in size and the balloons we put in the freezer decreased in size. So because of this, we concluded that the relationship was direct. What that means is as temperature increases, volume also increases. As temperature decreases, volume decreases.
Question 4. One design flaw that we had was that we didn't have enough time to fully heat or cool each balloon to the correct temperature. Another flaw was that we couldn't control how much the balloon was blown up, thus affecting the volume, and different balloons take different shapes, so no two could be the same.
If we could change our experiment's design, we would make our test between temperature and volume last longer and use stronger, more elastic balloons. The reasoning behind this is that our heated balloon burst after 3 minutes of heating, and a mere 3 minutes of cooling did not make the balloon shrink as much as we think that it could have. Besides that one flaw, though, our experiment went very well with no kinks.
For the percent error part of this lab, our first possible error is when we were measuring the circumference of the balloon in the volume and temperature relationship lab. The volume may have increased in different parts of the balloon and not the part that we measured, affecting the amount of change that the volume underwent. The second possible error was that the balloons might not have had the same volume. When we were blowing into the balloons, it is very likely that we did not exert the same amount of force, therefore making one balloon have a slightly greater volume than the other. And the third possible error were that the gases in the balloon as well as in the flask were most likely not identical to one another because the classroom air is composed of numerous and various molecules, making the compositions of air and gas different from one another. Therefore, this could affect the outcome of our results. We are now at the conclusion section of our lab. In the relationship between gas pressure, temperature, and volume lab, our group successfully observed the relationships between each of the variables. As textbooks say, our results showed the relationship between pressure and volume is inversely related, and the relationships between pressure and temperature and volume are directly related. In the pressure and volume part of the lab, when we pushed the syringe lid, which decreased the volume, the pressure increased because the particles were being compressed, and vice versa. In the pressure and temperature part of the lab, when the flask was placed on top of the hot plate, the pressure, in kilopascals, immediately began to increase. When the flask was placed in the ice, the pressure instantly began to decrease because the cool temperature slowed down the movement of the particles, and slower movement means not as much pressure. In the temperature and volume part of the lab, when the 2 balloons, one which is in the freezer and one which was held on top of the hot plate, were measured by circumference, the warm balloon's volume increased because in order for the pressure to remain the same, because the pressure is the constant variable in this case, the quickly moving particles needed more space/volume. The cool balloon's volume decreased because in order for the pressure, the constant variable, to remain the same, the slowly moving particles needed a smaller space/volume.